Right, good afternoon, everyone. Okay, so today we are going to switch from question answering into a new application, namely summarization. This course won't have like a winding down phase. We will keep cracking on, and there will be a lot of important until the very last lecture. This is kind of because we had to go over that basic background of machine learning and deep learning. So now we have lots new, more advanced content to cover. I hope you are paying attention to the notes I'm sharing over announcements. These are meant to complement the lecture. So for those of you who are actually checking them, you'll see that I just rewrite what I taught you in the lecture in a little bit more precise way, but also sometimes I add things I didn't talk about in the lecture and I don't plan to cover again here. For example, in the last notes, I sent kind of like a little guide of how to make sense of all of those choices for different retrievals and different answer extractor or generator and so on. So just pay attention to that. And then for the practicum, you're going to come to your usual places. I want to warn you to kind of approach it as you would the second practicum. So there was a lot of PyTorch there and a lot of implementations of basic parts of your neural architecture. It's going to have a flavor of that. I know that second practicum required a little bit more time from you, so I expect that this one will have very similar kind of, okay, every minute counts setup. Let me just think about practicum. Yeah, so I will look at your own solution to your homework and kind of think about, okay, this is where I used linear, this is how I implemented tension, and so on. Like a little bit of going over how you approach implementation of transformer will certainly be helpful for the practicum. Yeah. Any questions before we move forward? Yes, please.
So there won't be any more projects after this, but you mentioned that there was a fifth project. Is there any way you could just release that? Just so we can go through it?
Yeah, sure. I have two more notebooks that you guys want to work on. One is about quantization and key value cache that we're going to talk about in future lectures. So how to use LLMs more efficiently and how to train a model with QLoRa. And then there is a smaller round with mix of things like today we are going to learn how to use, how to evaluate text generation. And then in that notebook you have, use calculate bird score and something like that. So I can definitely share those, yeah. If I forget, please remind me. I keep saying I will do this and that, and then I forget, yeah.
Can I actually ask a follow-up?
Yeah, of course.
So you mentioned quantization. You have like a sort of description of how much that impacts accuracy? Because I've done quantization on nothing with NLP or I guess language modeling. In quantization, it barely affected my accuracy with English. Why is that the same case?
Standard quantized version of a model. So for everyone to understand the context, we'll learn about this approach where we take our model and then instead of storing it in a full float precision, we are going to set it in a much lower precision. And we are going to continue fine-tuning a lower precision model without losing accuracy. So there was a period of time where this wasn't working, but these days it's pretty standard to use quantized models and fine-tune. So QLoRa is assuming your model is quantized, it has few other extra nice steps about, storing gradients and things like that, and more targeting specific parameters, and that's how it's trained. So that's super standard today. However, I just noticed a survey of someone doing a very large scale evaluation of quantization. So although you don't lose accuracy, your test set might not be reflective of the things you might be losing. So is your model equally biased and things like that? Maybe a question you can ask. So I will try to again remember to share that survey as well. I'm going to get to that. Yeah. Okay, but today we're going to start with a new application, which is summarization. And unlike question answering and retrieval that took us really long time to go over methods here are going to be fairly quick because we have all the bits and pieces. We just need to apply them to summarization. But let's talk about what is summarization. So here is some article I pulled in 2024 where, Boeing crashes were concerning. They're kind of still concerning, so still a relevant topic, unfortunately. And then this is the article. And a very realistic application is trying to summarize an article, right? Like, if you have like Google News Trends or things like that, these are basically summarization tools in the background. So let's read this article together and try to figure out which sentences we would, or part of sentences we would include into our summary without me giving you a definition of summary. Let me just see whether, okay, this is working. Okay, so, okay, how to go in. All right. I'm going to read a piece of text and then I'm going to assess from you whether we want to keep this text or part of it into our imaginary summary. So it starts with federal regulators are investigating a whistleblower's claims about flaws in the assembly of Boeing's 787 Dreamliner. Do we want to include that? Yeah. Okay. I would agree. I feel like this whole sentence is very important. And actually, you will see that a lot of summaries tend to include the first sentence because usually when we write news articles, I mean, we never write it, when journalists write them, they want to place the very important piece of information first. Okay, so then we have longtime Boeing engineer, Sam Selpur. Is that how you pronounce this last name? Selapur. Okay, went public Tuesday with a claim that he observed problems with how parts of the plane's fuselage were fastened together. Okay, it's a long sentence. Do we feel like the entire sentence needs to go in summary? Which parts?
Fuselage.
Fuselage. Okay, it's good to know I mispronounced that as well. Okay, so you say plane's fuselage. Is that how you pronounce it? Okay, so that's the problem, right? That's where the problem is. I feel like for me, the fact that this person is a long-time engineer has a more weight to their claim. So I would include their, this part, but maybe I'm not so interested in their name in the summary. Maybe if I'm really interested to know more, I would look into. I feel like Tuesday, maybe whatever. So yeah, long-time engineer, maybe reported planes fuselage issues. I would kind of keep that. All right, so then they warned that production shortcuts could significantly shorten the lifespan of the plane, eventually causing the fuselage to fall apart in mid-flight.
Production shortcuts.
Yeah.
Fall apart.
Yep. Yeah, this part is really important, right? Okay, but we are seeing how we are selecting parts rather than full sentences. Then if left unchecked, this could result in catastrophic failure. They say Tuesday during a press briefing to discuss his claims. I've seen no. How about the middle part of the classroom? No. Yeah, right. So it feels a little bit repetitive. So
How long is the summary to read for? Or does it matter how long?
we are not having any specific definition, but this is a great point that you're looking at. Depending on what is agreed, length of the summary, we might make different decisions. So let's say we just want a few sentences, and I guess we would agree that then maybe this one is a little bit repetitive or implied by the previous one. Okay, so I'm going to skip to the last sentence. Boeing immediately pushed back. So what do we think about this one? Yeah? Anyone feels like whatever? I don't really need to know that.
It depends on what you're trying to get out of the summary in a way, because if we're like summarize like the problem, and it's not necessarily necessary, but if you're saying summarize like the two sides, like both side and the business side, then it might change.
Yeah, that's a very good point. There is also a notion of like, what is the summary for, right? But you said something really important, and that's that if you're trying to summarize information and there are different perspectives, including all of those perspectives is important. Okay, so we have kind of played around with this and seen which bits and pieces we would keep. Let me now figure out how to clear all of this. Sorry, second. No. No.
Trash can.
Yeah. Okay. So, and the article goes on, so we would repeat it. So basically what we have started to do here is we were trying to pick the right content for our summary, right? And obviously the thing we have all somewhat focused on is relevance, right? Like what information is really essential and relevant to the main point of the article. So here I think we all kind of infer that the point is to inform the public that there might be issues with the most common aircrafts they are using to go to different destinations. So I think we were all picking off like, okay, scary sounding things like, dropping down in the midair. What is relevant is really domain specific as well. So for example, here, I think we have chosen to include Boeing Dreamliner because we know that not necessarily every airplane has this issue and this piece of information may be relevant, right? So things can be quite domain specific. And as Joseph, you mentioned, like, what is the target length here, right? Like we have to balance the brevity versus completeness, right? Like we were starting to get the sense, okay, this might be nice to include, but okay, I have certain budget, right? And then we have also seen a case where we needed to decide whether we are including all of the perspectives as well, right? I think including all of the perspectives, especially in news articles, is quite important. Okay, so these are some notions of what makes a good summary. However, there is also a decision of how do we present, right? So I will show you one common way to do it, but I want you to remember that we have actually been selecting bits and pieces, and then we couldn't just like extract them and say, that's it, like here are a bunch of phrases, right? We needed to combine them in some ways. So we would need to maybe rewrite and paraphrase bits and pieces. Which brings me to these two very common ways to do summarization in NLP. One of them is extractive summary, and it was more popular at the age when we didn't have good generation models, right? So I think pre-2020, this was the most common way to summarize text. And it basically had required that we, for each sentence in our input document, we decide whether we include it into summary or not. So it's a binary decision. And we would do it at the sentence level, right? So here are 4 sentences I deem that are kind of representative of what this article is saying. So just to repeat, extractive summary is a summary we get by selecting sentences from the input document. Opposed to extractive summarization is abstractive summarization, where given a source document like this NPR document, we are trying to generate in free form a summary. So this summary includes rewrites and re-expressing of the content, which we can do freely, right? And since we have in this course talked about language modeling a lot, this might even seem like a more natural way to approach this for you, right? So we can start with our document and then use next token prediction to token by token generate the summary. So this is abstractive summarization. And we're going to really quickly go into how to model this. As I said, you know all bits and pieces of how to actually do this. So today's lecture, we will just quickly go over this. And then what is very unknown to you right now is how do we evaluate summarization and other text generation like machine translation, and that's going to be a major focus of today's lecture. But let's go into quickly into these approaches to summarization. So if we have extractive summarization, meaning we are trying to decide which sentence should belong to our summary or not, then this should evoke in you a sense of binary classification, right? Every sentence you classify it either into include this sentence into summary or do not include, right? So the way we do that is by using our encoder-only pre-trained models like BERT. And we use those special CLS tokens to separate each one of these sentences. And we pass our inputs through BERT, as we usually do, which means that at every token, we are going to get new, highly contextualized embedding. And then we are going to take the CLS token of each sentence and use it to predict whether to include it or not. So we are going to have a classification head, of course. It's going to be of the shape, the size of our final token representations by 2, because we have 2 classes. And it's going to give us the distribution over these 2 classes, and we are going to pick whatever is the most probable one as a choice here. Training data will, of course, include this information. So our training will include negative log likelihood training, where at every single one of these decisions, we get a loss, right? Like if the true class here was include this sentence, we would take what is the probability of class include for this specific token here, right? And we will get that from taking a right value from our softmax factor as always. So since we are going to have multiple CLS tokens, we are going to have multiple negative log likelihood losses. We are going to average them, take the average to backprop and change the weights of our model, which will include the classification heads weights together with all of the BERT weights, which include weights we have for self-attention and feed-forward lengths. The only thing that's somewhat unknown to you are these segment embeddings. I kind of intentionally skipped them when I talked about BERT, but actually encoder-based models like BERT have, together with their token embedding and positional embeddings, they also have the segment embeddings, which are used to separate different text types more strongly. So here we have different sentences, so we can have in the original BERT, we had only 2 segment embeddings for A and B to kind of differentiate. This is some kind of text and this is another, because you probably now also have a feeling that a lot of times, like we have a document and something else, like a question, right? So it's quite useful to have 2. And we learned these special embeddings for segment A to segment B, and you can use them to kind of delineate different text types. In practice, I think they have shown to have marginal effects, so you can ditch them and you wouldn't have a huge decrease in the performance. So yeah, just remember that together to token and positional embeddings, we also have the segment embeddings. Think about just A and B, like 2 text types, and only 2 extra embeddings we learned, and we added them together with token and positional embeddings. Okay, any questions about this? Yeah, so I would say that you have seen this multiple times. What has changed here, you have multiple CLS tokens, right? And we are having classification head that is for a single instance applied at multiple CLS tokens, so we average the loss, right? Previously in classification of, let's say, movie review, we had just 1 CLS token, classification head applied to it, and 1 loss. And that's basically it. That's the whole difference. Okay, so pretty straightforward. And our abstractive summarization is equally straightforward. I'm trying to kind of go over next token prediction again. I feel like some repetitiveness won't hurt us. So remember, we have talked about next token prediction many, many times in this course, and I'm just repeating yet another time how to do it, right? So in abstractive summarization, we have as a source input our document or more documents that we want to summarize. And our goal is to, with next token prediction, to generate the summary. And our training data will include human-authored reference summary for some documents. Okay, so as always, our task here is to first, let's say we are going to use decoder only transformers like Llama, Quen, Olmo, because we know that decoder only models are kind of the state of the art today, and they are great at text generation, unlike encoder only. We are going to use teacher forcing, meaning whatever is the generated token or likeliest token or among likely tokens, we are going to use what actually had appeared in a human-authored gold reference summary. So we are going to start with encoding our source document. And remember, I think this might not fully land for some of you. We are going to encode these tokens, source token with decoder blocks, but we have causal attention there handling everything for us as well. We don't really care about the loss at the source token, right? Like that we are just trying to encode them at every decoder block because causal attention will need representation of those source tokens to calculate for once we start to encode target tokens, how important those source tokens are to the target tokens, right? So we need their representation, and that's why we are passing them through our decoder blocks. But we have that LM head, we just don't care about it, right? We don't absolutely need to use it here. It's only once we have encoded the source document and we start to try to generate the next token where we start to calculate our loss. So here we had encoded our source sequence, and it's time to predict the first target token. Let's say that's company. Here, I'm not going to actually sample company. I am just going to calculate the loss, right? I just need the log softmax. I don't need the actual displayed token during training, right? So I calculate whatever is my negative log softmax for the actual token I needed to predict, and let's say that's company in this case, and then I do that token by token or position by position. Here, I wanted to show that even though the earnings might be the most likely token for under the model, we would add whatever is the in the human-authored summary as we are using teacher forcing. One thing maybe that I didn't emphasize a lot while teaching you next token prediction previously is that at every position we calculate this loss, right? In the end, we are going to average these losses to get one loss that we are going to use to back propagate through the decoder weights. So meaning LM head weights and the representation, so self-attention plus fib over layers weights. So yeah, another thing I want to mention here is that although here you see how I kind of visualize this position by position, because of causal attention, and I think you can really understand this only when you start implementing this, it's really hard to fully visualize that without code. If we place all of these source tokens and target tokens in their inputs, because of causal attention, which will take care that we don't look into the future, we are going to get as an output a tensor, which is of the size of number of tokens in the input, right? We are going to ignore the source tokens losses. We don't need those, right? So we take only those that correspond to target tokens, and we're going to average that loss and then back propagate, right? So during training, you can implement for the forward and in future as whatever you like, but you will never see a for loop during training where we go position by position, right? We are going to always give an input of integers, which are the vocabulary IDs of our tokens, and we are going to get as many losses as there are input tokens. If we are doing conditional text generation, we need to ensure that we ignore the source tokens losses. If you are just doing the pure language modeling, not conditional, then all of the positions are, and all of the losses, like in your hover, are. So I don't know how else to kind of visualize this, but I hope, like, as you are implementing this, you kind of embrace this for yourself, that there is no iterative approach here. Yeah.
So, just to clarify,
Mhm.
causal attention is the reason why we can take this tensorized approach to training rather than iterative?
Yeah, if you didn't have causal, like with causal attention, you are kind of mimicking, constructing these partial inputs, right? So see, when I'm trying to predict, let me put here, blah, 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 the company and then profits, I'm trying to predict the next token beat. With causal attention, I can give in my input the full sequence, including all source and target tokens, right? And my causal attention will ensure that my profits doesn't look into next token, beat, and so on, right? So this is why you can start with the full sequence, and then causal attention will make sure that you're basically simulating having these partial inputs when predicting the loss at a given position.
Okay, since it's all the inputs coming together.
Yeah.
You're not looking forward, you just do that tensorized thing to go
Yeah.
across all those things.
Yeah, exactly, right. If I was doing this iteratively, I will have this partial input and my attention would have no choice but to look at the previous token. But when I give everything in the input, then if I didn't have causal attention, I could look into the future, which would be bad, right? Like that wouldn't be accurate description of what happens if when I have partial inputs, and also would be cheap. So yeah, I hope this is a little bit clearer now. And also, like, there is nothing new, as I said here, we have used the same approach for machine translation, right? Instead of our source tokens being some input document, there were source token in some source language, and we're trying to produce target language tokens. And every other application, right? Like with text generation, for example, that answer generator, the document was some relevant document, and our target tokens were the answer tokens, right? Same approach, always the same, just what is the input and what's the, or source and target is changing. Okay. Another thing that's kind of becoming really hot these days is to summarize really long, something like book. And here we need something a little bit more smart, because there is just such a long input to remember, right? So what you're going to see here a lot is that people take this long input, like a book, they divide it into chunks, and then they summarize each chunk. And then they take two consecutive chunks and they prompt the model to generate the summary for those. Now you have kind of like a summary of two chunks in the model, and then you take those intermediate summaries and you combine them again. So basically, you are kind of building this hierarchy of summaries until you come to the summary of the entire book. For example, here we have 4 chunks. We first summarize each chunk. So we get S1, S2, S3, S4. Then we find a joint summary of S1 and S2, and S3 and S4. And then we finally create a full summary of these merged summaries. So yeah, just so you know, there is this new line of work that is trying to summarize very long inputs, and here the approach doesn't really change. You're still generating next token prediction, right? But the condition, the source tokens can be these intermediate summaries, and you're kind of hierarchically building this representation. Yes, please.
When we get to that third step where we merge sort of these joint summaries into another
Yeah.
summary with context, let's say that we're dealing with, more than 4 chunks here. Is there another summarization step where we take that merged summary and do a summarization of that until we get something smaller, or?
So after you have these merged summaries, then you will merge them all into one big summary that's going to be a summary of the entire book.
Okay,
Yeah, so you see that S like in a star, that's your like file.
that's the finding, okay.
And I mean, how people approach this, there is probably a lot of different approaches to this. I just wanted to mention that sometimes you can't just have a next token prediction. So here, this previous approach that I mentioned, where you take your source tokens, here our source tokens would be a book, and then you could try to generate, summary of the book token by token. But that's going to be really hard for the model because there's just so many source tokens to remember, right? So what I want to kind of more high level point here to remember is when the input is super long, then you need to kind of do a little bit more creative approach to making sure that all parts of the book or another long context are actually remembered. Yeah, but books are really long, so keep that also in mind, like when this is actually important. Okay, so now I want to move into evaluation of text generation. We have learned about abstractive summarization and machine translation, but I actually never taught you how do you evaluate whether your translation or summarization system is good. And today we're going to talk about that at length. So let's look into what is relevant for, let's say, machine translation evaluation, and then we are going to talk about summarization evaluation. So now for the rest of the lecture, I'm going to go back and forth between translation and summarization because these are both text generation applications. So for translation evaluation, what we care about are adequacy and fluency. So we want our translation to adequately and completely reflect the content of the source sequence, right? So that's obvious. But also we want to translate in a way that reads like a fluent language in our target language. So for example, here we have three different translations of the Spanish sentence, a Vinay le gusta Python. The last one, Vinay likes Python, is both adequate, it reflects the content of the source sentence, and it's also fluent in English language. Now, this Vinay debugs memory leaks obviously isn't adequate. It has nothing to do with the actual source meaning of its sentence, but it is fluent in English language, right? And other way around here, to Vinay, it like Python, it kind of suggests what the content of the source sentence is, but it does it in a really influent way. So this is just to show you that both adequacy and fluency are important. One without the other is not giving us a good translation. Then for summarization, abstractive summarization, and maybe I should just mention here that since we're talking about text generation evaluation, I'm referring to abstractive summarization, right? With extractive summarization, you would have test data where you would know which sentence was included or not, and you can calculate accuracy, precision, recall, F1, all of that. So for abstractive summarization, where we can, freely express ourselves when writing summary, this is where things get. So there are many aspects of a good summary and evaluation metric that we need. Some of them are comprehensiveness. So we need evaluation metric that tells us are the key points of the source capture. We need conciseness or repetitiveness, so then it's kind of the same thing. The metric that tells us is a summary appropriately brief without unnecessary information. Does it avoid redundancy? Is it faithfulness or factuality? Is the summary accurate? Like, does it actually talks about things that the source mentions, or starts to hallucinate something that was not said in the source? Maybe it misrepresents the source, right? And coherence, right? Like now you have multiple sentences and they should logically flow, right? Like one of the things I noticed when I edit the writing of my students a lot of times is just logic. Why is this sentence following this other one? And our summaries have to have the same quality, right? Are there any metrics I taught you that could capture things like that? Like these here on these slides. maybe there is only one, and maybe you can only capture one of these. Do you feel like mostly there isn't one? Oh, suddenly there's so many hands. Okay, I'm gonna focus on folks who didn't mention all of these for reason.
Maybe repetitiveness, you see what words appear more frequently.
Yeah, so we can use some kind of n-gram statistics, right? That's a great one, and one I completely forgot. Do you have another one, or this is what you had in mind as well?
Yeah.
Yeah, again, this can kind of give us, okay, if we deem the summary to be Googled and we have some kind of overlap metrics, maybe in this way we capture the first one, are the key points from the source capture, right? Great. Another one I completely forgot that we could use, so this is great. There's also another one which I have in mind.
You can make a dot product with different areas to see if it's repetitive or factually correct.
Okay, so we have our generated summary for each maybe sentence. We kind of made some kind of vector representation and that check the dot product with document representation. That's an excellent one and would capture coverage very probably really well as well. Anything else? How did we evaluate language modeling, like intrinsically? Perplexity, right? So remember, perplexity gave us this notion of surprisal, right? So in a way, you could maybe suggest that maybe we can capture coherence with perplexity, right? Like if something is really coherent, it should have very high surprisal under perplexity measure, right? So, and sometimes we use that, but it's not a great one. Okay, this is very cool because I completely forgot that lots of things you already know and that you have actually proposed very close to at least two measurements, automatic ways of evaluating text generation. But we will see also that they are not a great choices. So why is text generation hard? It is hard because there are many valid ways to translate or summarize something, right? So just as an example from translation, I wrote here a bunch of translation of the English sentence, the cat sat on the mat in Croatian. So the first four of them are basically the same, except I have used different synonyms for the word mat in Croatian. So you can have prostirci, otiraču, strunjači. Sorry, not first four, but first, third, and fourth differ only in me choosing a different word for mat in Croatian. Now, I told you at some point that English nouns are mostly neutral, and in other languages like Croatian, all nouns have gender. So here, a cat could be female or male cat, right? And depending on which gender this cat has, I can use either mačka or mačak, which are different words for cat in the different genders. So first of all, we have this linguistic phenomena exists in one language, doesn't exist in another, like gender having grammatical role. We have synonyms, right? But Croatian is also very flexible in how we can place words. Like the word order is really free. So I can say mačka je sjela na prostirci, but I can also change the syntax. And I can say na prostirci je mačka sjela. I can say sjedila je mačka na prostirci, and so on. I can really shuffle these words, and all of these will be grammatical sentences in Croatian. So the point I'm trying to make here, from one sentence, I have created many equally valid translations in Croatian. And now, like where previously with classification, we had like one ground truth, here we have many options, right? Another issue here is subjectiveness, right? So when we were picking what to use or not in our summary, all right, this time around we had pretty solid agreement. Some other times when I was picking things with students, they would disagree with what to include. And this is because there is subjectiveness of what is truly repetitive, what is truly naturally sounding, what is truly important, right? So different people might have different assessments of the summary quality. Okay, so let's look into, we are going to have human evaluation, which will mean we are going to recruit some people who are going to tell us about the quality of our summaries or translations. And we are going to have automatic metrics, which some of them were suggested just a few minutes before. So human evaluation, when a person gets a summary and translation and they are trustworthy annotator, their assessments are deemed gold standard, right? In the end, it's people who are going to look into the outputs of these systems. So whatever is their assessment of the quality of these outputs is what matters, right? So human judgments of translation and summarization quality are deemed gold standards, assuming you have trustworthy annotators. Nice thing about human evaluation is that it can capture nuanced aspects of the output, right? Like we people understand nuanced phenomena, so we can ask questions like, is this a good flow, right? Like, is it appropriate for this application domain, and things like that. And we can also evaluate complex criteria. If we had enough resources to pay our annotators for their time, they can evaluate whether something is factually correct, for example, which is really hard to do automatically. What do you think are downsides of human evaluation? Yeah. You have to pay the annotators, right? So it's costly, right? And what do you think the one immediate consequence of the cost? Besides needing the money, money will be blue, right? So one obvious consequence will be that we can't evaluate as many as we would like, right? Like we will have a small sample size, right? Some other ideas? During your homework, I didn't really ask you maybe to use this set a lot, but did you tune your hyperparameters? Yeah, right. And then you got a new version of a model, hopefully a little bit improved, and you check the accuracy again by rerunning new model version on the dataset, right? But here that would mean, oh, I realized with my human evaluation, I really need to change so and so. But now to test whether so and so had positive effect, I would need to rerun my expensive human evaluation, right? So iterating and model development is not really an option. Yeah, so we need to kind of make hard choices early on. Okay, so we said it's expensive, time consuming, therefore doesn't scale to large data sets. And it kind of doesn't allow rapid iteration during model development. Another thing that is relevant here is that people will have different view of our guidelines. And although we write instructions and have something specific in mind, they will still have their own flavor to these instructions. So you will get subjectivity, and with subjectivity, you will get disagreements with people. So let's say we go to 3 people, document and a summary, and we ask how good is the summary, and on a scale from 1 to 5, one says 2, the other says 4, the other says 3. It's quite mixed, right? And you can aggregate the result, but it does really capture that there is such a huge disagreement, and that maybe the person who gave 4 is actually right under our guidelines. It's also difficult to reproduce. So if I hire some annotators, later you won't get the same annotators. So you might not get the same outcomes with different set of people. Okay, so automatic evaluation is desired, right? Like we want to have some metric which tells us this is a good summary, this is a good translation. And in this way, we can iterate during the development a lot, because it's going to be fast, cheap, reproducible. It's going to scale to millions of examples. The downsides are that finding a metric, automatic metric, which correlates with trustworthy human judgments is really hard, right? Don't forget that human judgments from trustworthy annotators are gold standard. They are the thing we want our automated metrics to produce. But developing automated metrics which says that the summary is good, the translation is good, when a trustworthy annotator says so, so far is being really, really hard. So that's the biggest issue. You could use these ideas we are going to talk about today, but they might be not correlated with these trustworthy human judgments, and they might be optimizing for profit. Okay, so let's talk about how we do human evaluation. Then we are going to go through a bunch of evaluation automatic measurements. There are two ways we can do that. First one is pairwise comparison. This is when you want to compare your translation or summarization system with another. So there is a state-of-the-art in the field, and you want to say mine is better. Mine is significantly better. What you can do for the same documents, for the same source text, you can create your summaries and summaries of the state-of-the-art. And you can present person with a document, and you can say, here is summary 1, here is summary 2. You never say which comes from which model, and you shuffle the order such that one's models is not always the first summary, so they can't pick on these things. And then your annotator says, I prefer this one or the other. And later you report how many times your system beats the other system, right? Like we call this win rate. How many times your summary was preferred over the others from the other system. And this rate should be higher than a losing rate or losing together with the die. Sometimes you might be proposing a whole new summarization task. We are not trying to beat anyone. And here you might just do direct assessment of a single response. So here an annotator would see a document, your summary, and grade it according to some criteria on a scale from 1 to 5, typically. Sometimes you also want to show some kind of human-authored summary here. And this is just because you want to prime these different participants in this study to kind of have the same notion of what you think is a good summary. So you can say, please rate this summary. I think this one specifically, the other one, the human-authored one, we don't say it's human-authored, but we just show it and say, I think this is a good summary. So relative to what I think is a good summary, can you rate this generated summary? And this is called reference-guided grading. Now, there's also a question, should you provide a definition of summary quality or not? Should you leave it somewhat subjective? In some works, they don't actually provide annotators with specific definitions to avoid introducing our own biases of what we deem is a good summary, where someone else's view can be equally relevant, right? Which of course then invites this issue of subjectivity. However, in some domain, like medical domain, very typically you would give very detailed guidelines because stakes are higher, factuality is extremely important, and so on, right? So how to actually design this user study is domain specific. I know this is super tiny. I just took a screenshot from someone's study. I would say this is an example that's not super nice for annotators. You usually use more colors, larger text, and so on. But here, what I wanted to actually show you is that sometimes we also have very fine-grained evaluation. Instead of just asking, hey, is this a good summary on a scale from 1 to 5? You can ask about different aspects of the generated summary, such as, is it consistent? Is it relevant? And so on. Is it coherent? And so on. And for each one of these aspects, the annotator was giving a rating from 1 to 5. So this is an example of what an annotator can see. Imagine there is an actual news article, and then they need to decide. Sometimes just is it consistent, inconsistent, but sometimes on a scale from 1 to 5, is it relevant, is it coherent? For translation, you would similarly ask your annotators about aspects you care about, such as fluency and adequacy. So, for example, you would ask them, how do you judge the fluency of this translation? And they need to rate it from incomprehensible to flawless English, or for adequacy, you can ask them, hey, how much of the meaning expressed in the reference translation is also expressed in the hypothesis translation, and they can rate it from none to all. Let's just talk a little bit more about the protocol here. So first, you would design your study. So that means creating those templates like we have just seen. You can use, if you're having this simple form-like questions, you can use Google Forms or Qualtrics or something super simple. Once you have your study design, you need to find people who will do the study for you. And for this, you typically turn to crowdsourcing platforms like Prolific, Amazon, and Mechanical Turk. Your number of your document summary pairs should be at least 100. I think no one would trust your results if you had less than 100, and even 100 that is a little bit small, like 300 would be better. More of that would be amazing. So anything less than 100, I think no one would believe that your results are statistically significant. And typically, we would have each one of these instances evaluated by 3 different annotators, at least 3. 3, 5 would be great. And we do this because we want to kind of get a sense of how subjective we would like to see some sense of agreement, all right? So it's okay if one person says this is a summary 4, like it's, rated 4, another one says 5. But if one says it's 1 and the other one it says it's 5, if we have such a large disagreement, likely something in your instructions needs to be revised. They're probably too open-ended, or you might be dealing with what we call spammer, a participant that doesn't really engages in your task. This is why we usually also have pilot studies where we have, instead of running the whole study with 100 instances, we start small scale, like with 5. And we check, okay, do we have huge disagreement? And do we have these spammers and so on, right? So there is a lot of piloting until you get to, okay, I'm going to run the full evaluation. I won't talk about these metrics, but there are different measurements you can use to evaluate the agreement between your annotators. They come from statistics, and you can use them like off-the-shelf tools. And then in terms of compensating your participants, it really varies from researcher to researcher, but a minimal hourly rate in certain states in the US is going to be $12, and a good guiding principle is to take minimal hourly rate in one of these states. There are states where it's lower, but you typically take the high end of that. So you would typically see rates between $11 to $15 per hour when you don't need experts. So here, if your summary is something any layperson can evaluate, if you need a clinician, then your hourly rate would be higher. When else? Yeah, I think I felt like there is another aspect of participants where we pay them more besides their expertise, but now it slipped my mind. So yeah, doing this, it takes a lot of practice to do right. I think we have one course on experimental design with human subjects. If you envision you will ever run studies like this, I highly recommend taking a course like that. If you are working at institutions that are federally funded, like universities, you need to also have IRB training, which would allow you to then actually conduct studies that involve human subjects. For many of this NLP stuff, they will get exemption, but it's actually a really good training to go through, and it comes from really bad sides of the history. So I think we are all having, as a society, due diligence. But not everyone has to do this. I worked at the Allen Institute for AI, which is a nonprofit, and we didn't need to do IRB just because we were not federally funded. So it's a little bit, like at the university, you need also, you usually don't, a bit weird and arbitrary. Okay, so kind of to wrap the human evaluation, as I said, it's gold standard, right? Assuming you have trustworthy annotators, not spammers, and you get these human judgments, and you have some resemblance of agreement between your annotators, or I should say, if you don't have like huge disagreements, then those judgments per instance are your gold standard. However, as I said, challenges here are, you need to deal with what happens if you have a disagreement. There is a lot of piloting over your having the right study design. Sometimes you need experts, and experts are not going to be easy to recruit. Like clinicians are simply not just waiting for this kind of work. So you will need to compensate them a lot, which will means you will need to have a bigger budget for your evaluation. Then if your inputs get really long, like it's the case in summarization, your annotators get fatigued and the work starts to be of lesser quality. These days, doing crowd working is really hard because quality control is difficult. So a lot of today's annotators are using LLMs to do this annotation, which beats the whole point of using doing human evaluation. And it's really hard to control for. My PhD student, Fatima, some of you met her in the practicum. She introduced all these checks, like you can't copy and paste into the study, you can't screenshot, and all sorts of things, but it's still, we didn't feel like we are getting responses, even from Prolific, which is deemed to be higher quality than Amazon Mechanical Turk, that we've deemed trustworthy. So these days we are recruiting a lot in the network as well, finding actual real people we know to do these tasks. And then due to the small size, like 100 instances, statistical significance is always the question. People doubt that these results are truly statistically significant. Okay, but still, it's a holy grail, right? It has all these issues, but it's still the thing we can rely the most. So with automatic metrics, we are trying to get a measurement that's automatically going to give us a score that is correlated with this human judgment. So if you have, for some translations, average between these three annotators is 5, or whether this is an adequate and fluent translation, we want a metric that gives a number which is really high. It doesn't need to be exactly 5, it can have different boundaries, but we want it to be high when people say that the quality is high, and opposite. If people say quality is low, we want the metric to give us low number. So some of you had here on this side suggested we can look into these lexical overlap measurements, right? So we have generated summaries or translation, and we have some human authored summaries or translations. And we can use lexical overlap metrics that measure how many n-grams overlap as a way to say whether the generated summary is good. Like if the lexical overlap with the human authored one is really high, that would suggest it's good. So one of the most popular metrics for translation, and probably the least beloved one, is BLUE score. It has been used a lot for machine translation. And it is basically, this is a scary looking equation, but what it's trying to do is measure the n-gram precision. So we check among n-grams appearing in the hypothesis generation. Remember, I said this once, but it's been a while since we learned translation. Hypothesis translation is a generated one, and reference translation is the human authored one. So within the generated n-grams, we are looking how many of them had actually appeared in a human authored reference translation. So it's, as always, the notion of precision, right? You can notice here we have PN because we are looking at specific number n for n-grams. And the actual BLUE score will be geometric mean of the precisions for different n-grams. Now, there are a few extra little details, and do not ever try to attempt to implement your own BLUE score. So always use the existing library because this is so easy to mess up. But we are going to use smoothing. Remember, we learned smoothing when we talked about classical language modeling with when we were counting n-grams, where we just add a little bit probability to avoid here dividing with a 0. No, sorry, when we in the denominator, when we have a 0. If we have n-gram that appears multiple times in the reference, we are going to use it only once, not as many times as it appears, but because they can unfairly favor generations such as repeating 2, 2, 2 here against to be or not to be, right? So to be appears twice, and if we check precision against to be each time it occurred, we would give more score to this obviously rubbish generation. And there is also something called brevity penalty, which is applied to translations that are shorter than reference. These little points are not so important to me. The higher level point that is important for me, for you to understand, is that although this is the main equation for blue, the actual implementation has various little hacks to make it working. So always use the blue score that's implemented in a library that everyone is using. I will find it and share it. Okay, so one immediate showcase of why blue is not beloved is here. So we have, again, reference Vinay likes programming in Python, and we have 3 generations. To Vinay, it likes to program Python. Vinay likes Python, and Vinay likes programming in his pajamas. These are the blue scores, right? And here, something should immediately ring a bell for you. So how are these blue scores looking?
So it would appear that the blue score is highly dependent on the reference that's being provided. And with system 3, we see that there is pretty much perfect overlap between the reference and the system, aside from the last part. So blue score is high, but that very important keyword of Python is ignored this part.
Yeah, and not only that, but there is a boost. I mean, here we are not penalizing this generation for saying in his pajamas, which was never mentioned, right, in the real summary. And so despite sounding really bad and much worse than the second one, Vinay likes Python, we have rewarded this obviously bad generation with the score. Yeah.
Why did the brevity penalty get introduced in the first place? Because like you're saying, system 2 is obviously best out of those 3.
I think this probably goes to the this one being really short, right? Vinay likes Python. I think here P3 and P4, which are for 3 grams and 4 grams. Obviously 4 grams here is going to be 0 because it's short. So, and then for trigrams, it has only 1 trigram. So just by being shorter, it has been penalized in this standard blue form without the brevity penalty. So yeah, the fact that blue, a poor metric for automated text generation evaluation, has been heavily documented. So here I am giving you references from 2006 to 2020, right? Like it's just the issue that is constantly being brought up. And I kind of like this summary in this blog post, which is, it says 12 critical flaws of blue. Blue poorly correlates with human judgments. It's blind to most valid translation, poorly exploit multiple references, is unsuitable to evaluate short text, is sensitive to tokenization, is unsuitable for evaluating translation of high quality, lacks interpretability, overestimates adequacy, lacks discriminative power, exhibits technological biases tied to poor scientific credibility, unsuitable outside of empty evaluation, and so on. It keeps coming up. The reason why it keeps coming up is because we have recently things have changed for the better, but since before 2023, 2024, we just had such poor options. So people who wanted to research something that involves text generation simply didn't have anything else but to use metrics like BLUE for intermediate development, and then at the end to do human evaluation. This is why WMT has the evaluation shared tasks since ages ago. Every year there's a shared task, including 2025, that examines how to evaluate machine translation. So it's an ongoing quest to find a reliable metric. Okay, now I'm going to mention also another one of these lexical overlap measures that are also not that great. But this one, as BLUE was focusing on precision of n-gram overlap, Rouge is looking at the recall of n-gram overlap. And this might be immediately clear to you why BLUE is more associated with machine translation. You really want precision with translation. With summarization, it's really important to recall information, right? Like you need to inform people, and if you dropped really important pieces of information, like, the airplane might drop mid-flight, and then your summary is bad. So here we are looking at a total among all of the n-grams in the reference summary, how many of them are actually mentioned in our generated summary. And unlike combining, as we did, BLUE combined different BLUE values for different n-grams into the geometric mean, here actually we are reporting different Rouge for different n-grams. So you will see Rouge 1, Rouge 2, you won't combine them. Rouge 2 has shown to correlate somewhat well with human judgments for multi-document extractive summarization, but not for abstractive. And just here I have an example. I didn't have it for BLUE, but this is how you calculate. So you have reference, generate the summary, tokenize them, and then you check how many of them are overlapping. And then the denominator here is how many bigrams there are in the reference summary. So in this example of the quick brown fox jumps over the lazy dog, and a quick brown fox leaped over a lazy dog, we would get the Rouge 2 of 3/8. Now, let me go over challenges of these automatic methods that use lexical overlap. First of all, they require reference text, right? So you need human-authored summary or translation, and if you don't have these, you can't use BLUE or Rouge. It's going to penalize valid variations. So for example, here I had jumps and leaped over. That's not maybe exact synonym, but it is pretty similar, right? And I wouldn't necessarily penalize the generated summary that we had in a previous slide. Word order matters. So remember how I gave you those different translation of the cat set on a map in Croatian, and I said I can just switch order around and it's going to be valid, right? So if my reference summary was just one of those that I gave you, we will completely miss that it's okay to have shuffled order, but because n-gram is a sequence of n words, it just would penalize a generation that had completely different word order than the reference. I showed you that it's reported that these measures correlate poorly with human judgment, especially BLUE was criticized for low correlation with adequacy. And they can't capture fluency or grammaticality. So again, here I have reference and hypothesis, the cat set on the mat, the cat set mat on the hypothesis isn't that good, but BLUE would still be reasonably high for this example. So high BLUE is not something you can use to say this is highly fluent or grammatical text field model. So why would we ever use it? As I said, for a while we had no other options. So until 2019, this was all you had. So you would just use it because your hands were tied. These days, we are still reporting them. I like to report them just for reproducibility reasons. So if someone was trying to train my model, the generation model, they should get similar blue and rouge. So it's a good like reproducibility checkpoint. If you show me rouge and blue and try to claim something about your system being high quality, I would not trust you. I would just not think that's a good measure. And if, for example, if I'm reviewing a paper that just presents those metrics as their evaluation, that would be clear reject from my side. Okay, today we have also heard another way of another idea for evaluating, and that's embedding based. So one issue I mentioned on my challenges slide for lexical overlap measures is that they are sensitive to semantic variations such as synonyms or related words. And this approach will at least fix that. So at least we won't be sensitive to different ways of saying things like jumps or leaped over. So here with these approaches, we are going to represent text using our pre-trained language models like BERT. And we are going to measure similarity in our embedded spaces, right? The most popular embedding-based measurement for text generation is BERT score. BERT score is going to tokenize the reference and candidate generation, such as the weather is cold today and it is freezing today. Lexical overlap metrics would give us very low scores here because cold and freezing would be deemed like two completely different words. And with BERT score, we are going to first tokenize and then represent each token with its final token embedding coming from BERT or alike model. And then for each one of these reference tokens, we are going to find which candidate token has the highest cosine similarity between their token embedded. So basically here we have pairwise cosine similarity between every reference and candidate token. And what you would then measure is to measure recall, you would check for every reference token. We are going to find the best matching candidate or hypothesis token. And among all reference tokens, we are going to get the highest similarity, and then we are going to average those as a recall. And then for precision, for each of the generated tokens, we would find the best matching human authored token, reference token, and we will average these highest similarities across all generated tokens. And then we will, as always, combine precision and recall with harmonic mean to get F1. Even more advanced is BLERT, which is it's created by French researchers, so hence the name. But what they notice is that extra repetitions or ungrammaticality might still be the issue for BERT. So they wanted to create a metric which is more aligned with human judgments. And basically what they are doing is they're taking BERT and they are fine-tuning it with a new regression head. So meaning a head that's going to give us a score for concatenated candidate and reference. And the score that it generates should be high when a human person would say, this candidate and reference, that this candidate or generated summary is a good summary given this reference. So if a person would have given a high score for a generated summary or translation based on reference, we are fine-tuning BERT to give us numbers that simulate that. High numbers when human says it's a good summary or a translation, and low numbers when they say it's not. And do it in two stages. So first, they use synthetic training data. And this is just to prime BERT to give scores relative to simple variations of the input. So what they do here is they use Wikipedia sentences and they perturb them in various ways. They mask tokens and they have BERT fill the tokens to get multiple versions of the original sentence. They back translate it, meaning you take a sentence in English, translate it in, let's say, Croatian, and then back translate it into English. And you maybe drop randomly words. It's just kind of testing and making this new BERT version better for these slightly ungrammatical maybe versions of the sentences. So here, this is synthetic data, so they won't have actual human annotator giving them for this newly perturbed candidate and concatenated with the reference. We won't have a human judgment of whether this newly created candidate summary is good or not. Instead, they are going to use a noisy supervision, and they are going to actually use blue and rouge as scores that need to be simulated in this step. So it's going to be noisy, but it's going to start to prime this new BERT that's going to be used as a metric soon. Okay, so just to kind of go over how this works, we are going to have reference, and then we are going to have a candidate generation. Here we are going to basically have a Wikipedia sentence and a perturbed version of it. We are going to have a regression head atop top of our token embeddings. And we are going to take the CLS representation, its final CLS representation, and multiply it with weight matrix, which are just going to give us a single number, which is basically a vector, right? Now it's not a matrix anymore. And then we are going to take that number we got, and we are going to take blue score, and we are going to calculate mean squared error, meaning the difference between blue score and the score by this BERT model, and we are going to square it. And then in the stage 2, we are going to actually use human ratings. So here we are fine-tuning this regression BERT model to give us scores that people have given, right, in some data. So if some annotators rated some translation with 5, we are going to try to predict 5 for with our BERT model. And this is actually quite good, but it relies on you having your data, right? So here, this was designed for machine translation because of that WMT workshop, they had a lot of human judgments for translations. But now, if you are trying to design evaluation for your own task, and you have never run human evaluation, you don't have such data, right? And it might be worth considering, oh, should I collect some of this data and then design my own BERT metric? But then the question is like, how many of these data points you need, because they still had quite a lot in this stage 2. Okay, we're going to talk about one more of these and challenges, and then we are going to switch into LLM as a judge, which is more or less the thing we are using these days to evaluate next generation. So we're going to finish next week because on Wednesday we have practicum. Good luck with that, and see you soon.